In a bold declaration, researchers have announced the discovery of an entirely new planet, unlike any previously identified. NASA, famous for its revolutionary research, has disclosed that this newly found planet is intriguing not just because of its size and position, but also because it emits light that appears to be artificial. Could this groundbreaking discovery be a sign that we are on the edge of unlocking mysteries that will radically change our comprehension of the cosmos? Does this revelation suggest the possibility of life existing on planets beyond our own? As we delve into NASA's remarkable discoveries, we may soon uncover the truth behind these extraordinary lights. In 2007, NASA launched the Dawn spacecraft with a mission to investigate some of the most captivating objects in our solar system. Equipped with 3 ion engines, Dawn embarked on a journey that began with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn transmitted back intricate images and data, exposing Vesta's complex surface and rich geological history. Upon completing its mission at Vesta, Dawn proceeded with what was arguably the most exciting phase of its journey, an in-depth examination of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, a feat traditional chemical propulsion methods could not have accomplished. These engines provided a steady thrust, enabling Dawn to travel vast distances and establish a stable orbit around Ceres. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object within the asteroid belt between Mars and Jupiter. For many years, it was regarded as the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is the largest and most massive body in the asteroid belt, making it one of the most intriguing objects because of its distinct features. Scientists eagerly awaited the first detailed images of this mysterious world, which revealed bright spots scattered across its surface, particularly within a large crater known as a crater. These bright spots immediately attracted significant interest among the scientific community. Before the Dawn mission, the best images we had of Ceres were blurry, low-resolution pictures captured by the Hubble Space Telescope. Very little was known about this dwarf planet, and the prospect of obtaining close-up images promised exciting new insights. The Dawn mission aimed to deepen our understanding of the solar system's formation and the role water played in the development of planetary bodies. The bright spots on Ceres, which were also observed on other asteroids, were believed to be composed of highly reflective materials, possibly salts left behind by sublimated water. This discovery hinted at the possibility of cryovolcanism on Ceres, a phenomenon where volcanoes erupt not molten rock, but liquid water or brine. What exactly these mysterious lights are, and what they reveal about Ceres remains an open question. Could they be evidence of ongoing geological activity, or could they indicate something even more remarkable? Ceres stands apart from other bodies in the asteroid belt due to its size, mass, composition, and potential for containing water and ice. Unlike typical rocky asteroids, Ceres has a composition more akin to that of a comet, suggesting it may hold valuable secrets about the early solar system. After 2 years of travel, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking a crucial milestone in its mission. As it prepared to send back the first close-up images of the largest object in the asteroid belt, the spacecraft drew closer to Ceres, revealing a world previously hidden from view. The initial images of Ceres displayed a cratered surface, indicative of a long history of impacts. However, it was the bright spots within the dark, rocky terrain that captured the attention of scientists and space enthusiasts. As the resolution of the images improved, scientists developed various theories about these spots. Could they be patches of ice reflecting sunlight, or could they represent something even more exotic? Speculation ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's astonishment, closer inspection revealed that the brightest spot was not a single feature, but a cluster of several distinct spots. The most widely accepted explanation was that these spots were deposits of salt left behind by the sublimation of water. This suggested that Ceres may have, or still has, some form of geological activity capable of bringing water or brine to the surface, where it quickly evaporates, leaving behind bright reflective residues. These findings challenged previous assumptions about Ceres, offering a new picture of a dynamic and complex world. The possibility that groundwater or brine pockets exist beneath the surface raises intriguing questions about the potential for life elsewhere in our solar system. Ceres is often described as an icy world with a rocky yet porous surface. Unlike most asteroids, which are composed primarily of rock and metal, Ceres stands out for its unique composition. Its surface is made up of a mixture of water ice and hydrated minerals, including clays and carbonates, giving it a less dense structure than its rocky neighbors. This composition implies that Ceres contains a significant amount of water. Its rocky surface is porous, with ice and other volatile materials trapped inside, making it more similar to a comet than a typical asteroid. Scientists believe that Ceres has a distinct interior, consisting of a muddy mantle and a core rich in water ice, which accounts for about 50% of its total volume. The mantle is thought to be a mixture of rock and brine, surrounding a core potentially made up of denser materials like silicates. The presence of substantial water ice suggests that Ceres may have hosted liquid water in the past, particularly if its core was heated by radioactive decay early in its history. This internal structure sets Ceres apart from other asteroids and raises fascinating questions about its potential for geological activity and the role of water in its development. Moreover, the discovery of ammonia clays on Ceres points to the possibility that the dwarf planet may have originally formed in a cooler region of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, supporting the existence of surface brines. These insights into the composition and history of Ceres not only deepen our understanding of this captivating dwarf planet, but also provide valuable clues about the processes governing the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological phenomenon, especially when compared to the more familiar volcanic activities on Earth. Unlike traditional volcanoes that expel molten rock, cryovolcanoes are often referred to as ice volcanoes, as they eject materials such as water, ammonia, or methane. These substances can exist as liquids or gases in extremely cold environments, such as those found on Ceres. Cryovolcanoes on Ceres operate by allowing briny water with dissolved salts to reach the surface. When the salt water comes into contact with the vacuum of space, it rapidly sublimates, turning directly from solid or liquid into gas. This process leaves behind glowing, reflective salt deposits, which form the bright spots observed on Ceres' surface. The most famous of these bright spots is located in a crater called a crater, specifically in a region known as Spot 5. This area has garnered significant attention due to its high reflectivity and periodic changes observed by the Dawn spacecraft. These fluctuations are believed to be caused by water sublimation, suggesting that cryovolcanic activity could still be occurring, or may have occurred recently on Ceres. In addition to Spot 5, Ceres hosts several other bright spots, each with unique characteristics. These spots are not confined to a single location but are scattered across the dwarf planet's surface, indicating that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots underscores the dynamic and active nature of Ceres, challenging previous assumptions that it was a geologically dormant world. As the Dawn spacecraft continued to capture more detailed images, a wide variety of surface features emerged. Ceres' surface is covered with numerous craters, each telling the story of this dwarf planet's history. Let me know your thoughts in the comments section, and if you enjoyed this video, remember to like and subscribe. As the Dawn spacecraft continued its observations of Ceres, the scientific community remained intrigued by the planet's mysteries. Each new discovery raised more questions about the dwarf planet's past and its potential for harboring conditions that could support life. The presence of bright spots and signs of cryovolcanism painted a picture of an active world, far more dynamic than originally thought. This discovery suggested that Ceres might not only be a relic of the early solar system, but also a world where ongoing geological processes, such as the eruption of ice and brine, are still shaping its surface. The fact that Ceres could maintain such activity, despite its small size, challenges conventional thinking about celestial bodies in the asteroid belt. Traditional views suggested that small bodies, especially those located in colder regions, were likely to be geologically inactive and frozen in time. However, Ceres' ongoing activity hints that, even in the coldest reaches of the solar system, the right combination of heat, water, and salts might be enough to power cryovolcanic eruptions. Another significant aspect of Ceres is its potential to unlock important clues about the history of water in the solar system. Water is a key ingredient for life as we know it, and discovering that it may exist in liquid or brine form on Ceres opens up new possibilities for the existence of life in environments far from the warmth of the sun. The notion that water ice and liquid water could have once existed on Ceres suggests that other, similar bodies in the solar system, such as Jupiter's moons Europa and Ganymede, or Saturn's Enceladus, may also host conditions favorable for life, making them prime targets for future exploration. The possibility of cryovolcanism occurring on Ceres also leads to deeper questions about the mechanisms that drive such processes. How does the water beneath Ceres' icy crust remain in a liquid state despite the freezing temperatures of space? Could there be heat sources from within the dwarf planet, such as radioactive decay or tidal heating from gravitational interactions, that keep the water beneath the surface warm enough to remain liquid? Understanding the nature of these internal heat sources could offer important insights into the geological evolution of other icy bodies in the solar system. Ceres' dynamic surface features, ranging from its bright spots to its craters, help us better understand the impact history of the solar system and the ways in which smaller bodies have evolved over billions of years. Every crater on Ceres, each distinct in its formation, gives scientists a glimpse into the forces that have shaped not just Ceres, but many similar bodies throughout the solar system. Whether these impacts were the result of asteroid collisions or other cosmic events, they contribute to the unique character of Ceres and its role in the broader story of the solar system's development. Moreover, the presence of ammonia clays on Ceres offers another fascinating clue about its history. Ammonia is known to lower the freezing point of water, which could have allowed liquid water to exist on the surface in the past, or even today. This discovery suggests that Ceres may have formed in the colder outer regions of the solar system before migrating inward toward its current location. This migratory history could explain many of the intriguing features observed on its surface, including the presence of briny material, ammonia, and signs of cryovolcanism. As scientists continue to study Ceres' surface and interior, their findings are reshaping our understanding of planetary formation, the potential for life beyond Earth, and the processes that drive geological activity in the outer solar system. Ceres, once considered just another small, cold asteroid in the belt, has emerged as a fascinating world that challenges our expectations and invites us to rethink what is possible on distant worlds. The Dawn spacecraft, through its years of meticulous observation, has played a pivotal role in uncovering these new details about Ceres. The mission, which has provided the most detailed images and data of this distant dwarf planet, continues to be a cornerstone in our exploration of the solar system. Each new image transmitted back from the spacecraft reveals more of the planet's secrets, showing a complex and evolving world that was once largely unknown. These discoveries are just the beginning of what promises to be an ongoing investigation into the mysteries of the outer solar system. In the coming years, the scientific community will undoubtedly continue to study the data sent back by Dawn, looking for further clues about the potential for life on Ceres and similar bodies in the solar system. As technology advances and new missions are launched, it is likely that even more surprising revelations await. Will we uncover more signs of cryovolcanism or find even more evidence of water beneath Ceres' surface? Only time will tell, but one thing is certain: the story of Ceres is far from over.